What is d by dx of x power a? X power.
A into x.
Yes,
Power
so
a minus 1.
a minus 1, right. D by dx of a power x.
Log.
Yeah.
Log a.
A power x log.
A power x log a. Yeah.
A power a d by dx of a power a.
This is 0.
0, right. Good. So x power x separately should find. Let y equal to or u equal to or v equal to x power x, and then do it separate. Dy by dx you can find out, and then you can write it.
Yes, sir.
That is it. Okay. This one I think you can do, right? Separately you should do.
Yes, sir. This is both again d by dx of 4.
uv.
Yes.
Right. What about 12? What about 12?
So will this be the that one dy by dt and dx by dt?
Yes, parametric differentiation.
Parametric, yeah. That name
dy
also.
by dt, dx by dt also.
Yes, sir. So then find the values of both of them and then divide by.
Good. Question number 13. Again, inverse trigonometry. Question number 13, inverse trigonometry. Okay. So we will do it's 13 and 14. First, let's do 13. So 13 is very simple, easy. 13, what is that? If y equals sin inverse x and sin inverse of under root of 1 minus x square. So this can be simplified actually. I think actually this is not there in your syllabus. Okay.
Yes.
This is not there in your syllabus, but still, okay, just for your understanding. Y equal to this is sin inverse x. And this is sin inverse of under root of 1 minus x square. Now here, this is separate. Now we are let x equal to some sin theta or cos theta. Put x equal to cos theta. Let x equal to cos theta. Then what will happen?
So sin inverse of sin.
Minus 1 minus cos square theta, right? That is
Yes, sir.
sin theta, right? Which is theta.
Yes, sir.
Which is theta means
Yes.
theta equal to cos inverse x.
Yes, sir.
That is cos inverse x. So this means simply cos inverse x. Right? This is cos inverse x.
Yes, sir.
Like that. First, whenever you have, I'm telling again and again one point. Whenever you have inverse trigonometry, first you need to simplify. Yes, sir. I told you.
Yes, you did.
Simplify, then differentiate. This is it. So now I simplify. You see, dy by dx. Now we find sin inverse x derivative.
1 by root over 1 minus x square.
Yes, cos inverse
Minus 1 by root over 1 minus x square.
0.
Yes, sir.
Now 14 important. 14 important. 14, 15, these are all important. So we'll do 14. Actually, I can give homework, but this is little different models that you may not do it. So that's the reason I'm explaining. So here What shall we do? You have to tell. Okay, you tell your idea and I will begin. Yes, tell me how to. What is your idea? What we can do? What's your idea? Already, what is from that? What is your idea? Yeah, you can tell. So one thing I told you that whenever you have zeros, right, take the one function to the other side to. You
Yes,
see,
sir. To take all.
uh, yeah. So generally, you can do directly. But what happens is, if you do directly, it becomes difficult. And whenever you have root the square on both sides, it is easy to solve. So x square into 1
Y
equal to y square into 1 plus x square plus x square 1 equal to y square plus y square.
Yes, sir.
X square y minus y square x. This is what is right. Y square. So here xy, if I take common, x minus 1. If I write this common, minus common, then x minus y into x plus 1. I think we got it right.
Y. So xy is equal to minus x.
Xy plus x plus y equal to 0. Let's have one this time. Right. So here, x is there, you can send that side, and then x. And write this. I will write that xy plus y equal to minus x. Y x plus 1. Y equal to minus x by 1.
X plus.
Okay, then dy by dx. I typically I will have to prove this one. So dy by
Yes, sir.
equal to u dash v minus uv dash u v dash. That's one. This one v dash by v square. This if you simplify, minus minus plus x minus x gets cancelled. Minus 1 by x whole square.
Yes.
So here, what we did is we simplified to get this answer. Okay. So okay, but what happens? What if you directly approach? That means you saw this, you understand this is UV and it's also UV, and you apply derivative directly. What happens? If you apply directly, what happens is here you need to get the dy by dx only in terms of x. Only, but
Yes.
this is implicit function, implicit function. It is both in x and y. You will not get this answer. You will not get this answer. If you directly apply, you will not get this answer. You will get some answer. Dy by dx you will get, but you will not get this answer. Why? Because this is implicit function. This is both in x and y. Both in x and y. Answer you will get in x and y. Like that.
No, but only here you need only in terms of x.
In terms of x. So therefore, we will not do it directly. You understand answer is in x and y. Many times we saw
Yes, sir.
implicit function that there will be in both x and y. This side we keep dy by dx common, and then we send the other side and answer will be both x and y. So you can do it directly and see that answer will be x and y, but we don't want this. We want, for the sake, we need to find y value. First, what is y value? Okay, here the trick is, first thing is you see that what you need to prove. You need to find out dy by dx only in terms of x. Okay, in x terms. That's only x terms. This is the first point. So that is possible only if you find what is y. Y in terms of x. This is what you should do. Y in terms of x. Find y value in terms of x. How do you find? This is a simplification. You simplify, then find y value in terms of x like this. Then automatically, if you find dy by dx, you will get only in terms of x. Because first you are finding y value in terms of x, then you will get the answer also in terms of x. That's the trick. That's how you need to understand. So that even if other problem comes in this is the approach.
Yes, sir. We will get all the functions in one side.
Should I erase this one?
Yes, sir. I took it down.
15. You see, this is a function and x minus a whole square plus y minus a whole square equals c square plus a greater than 0. That this is a constant independent of a and b. It's independent of a and b. Understand? That means you see here what points you have is here dy by dx you need to find d square y by dx square you need to find two things you need to find. First derivative, second derivative, and find
Yes.
all of this thing you find, but is a constant independent of a and b. You should get a constant. You should get constant. That means not in x and y, but in terms in constant. That also independent of a, where you will not have ab also won't be ab, but c can be there.
So
What?
we need it in terms of C.
Yeah, only in terms of c. What else is there? X and y variable. They should not.
Variables and A and B should not be there.
Yes, constant, only constant. With that x and y should not be there, a and b should not be there. Means what else is there? Only in terms of c you need to find.
Yes, sir.
For that, you need to check your answer. You need to check your answer, right? So what I will do is I will keep this question like this. Then we'll proceed. Right? Yeah. First we'll find differentiate on both sides. Yeah? If you differentiate on both sides, what happens? 2 into x minus a. Yes or no? It's differentiation of x minus
Yeah.
right, next.
2 into x minus A plus 2 into y minus b is equal to.
No. Into is called differentiation. Is called differentiation is x minus a. 2 into x minus a and x minus
Yes,
differentiation is 1. But whereas
this
here
is dy by dx.
into d into level of dy by dx minus b cos 0. It's differentiation
0.
minus b is dy by dx minus 0. That's dy by dx equal to
0.
0. So now I got dy by dx. Dy by dx is minus 2x minus a by 2 y minus b change x minus a by dy by dx. But it's
Yes.
you see it's in a and b x and y. So, but clear indication that if you do all this, we may eliminate x minus a and y minus b. Y minus b may get eliminated. They may go away from doing this. So, hoping that we find b square y by dx. B square y by dx square. Instead of doing this, here only you can do, here only you can do. d square y by dx square. That's why, here u by v you need to apply u by v whenever you have u by v, that is little complicated than u by. So better you apply here only. Here 2 you can take and cancel out. Okay.
Okay.
So here x minus a का differentiate again. Okay, differentiate again. So what I
That is
1
1 plus dy by dx.
1 plus, yeah, so u by thrown u by, yeah, dy by dx, that's dy by dx
dy by dx into dy by dx plus
yes,
y minus b into dy by dx.
no, u v dash है ना,
हाँ.
dash u dash v करे u v dash
अच्छा. So then
u dash v plus u v dash means dy by dx का differentiation d square y by dx square.
हाँ.
In this you have d square y by dx square, which is dy by dx whole square. Yeah, this is dy by dx whole square, है ना? ये वाला तो
Yes, sir.
yeah, this one is also there. Minus dy by minus 1 by y minus b. ये वाला y minus. This is d square y by dx square is.
Yes, sir.
So the thing is 1 plus dy by dx whole square whole to the power of 3 by whole to the power of 3 by.
Yes, sir.
Yeah, whole square is there. If you square this, here 1 dy by dx whole square, and you are whole square हो गया 1 plus dy. This you see here. This is only there here.
You can cancel, no?
Yeah, this is only there here.
But again, denominator is also same method.
Yeah, this is directly there here. It's so that means what you have is now what we can say is now what we can say here is, see here I'll see like 1 plus dy by dx whole square.
Yes, sir.
This is what we have directly. This thing 1 plus minus is common. So minus if I take that, so this thing is equal to this minus if I send that side minus y minus b times d square y by b square. Right, this only.
Yes, sir.
This only
Yes,
I will side. Instead of writing this only you can send this side. 1 plus dy by dx whole square is minus of y minus b times d square y by dx. Okay.
Yeah.
So okay, from this what now again one more thing is here dy by dx here is dy by dx is also this minus of x minus a by x minus b is there. Okay.
Yes, sir.
Here if you see all these things now you can very clearly see that here we don't have any c, we don't have constant which we need to.
Yes, sir. That became 0.
Yes, so that c is not there. Yes, so what we should do is we have to bring all this in constant. So that how do we do that? So we'll take 3 by 2 means what? One more 3 by 2 means here 3 by 2 means what? 1 plus this 3 by 2 is nothing but 1 plus 1 by 2. So 1 is
Yes, sir.
already 1 is there. Okay? So yeah, what I will do. What we'll do is once we'll see this dy by dx whole square. Okay? because one more thing, one more we need dy by dx whole square. So this is dy by dx whole square. That becomes what, x minus a whole square by y minus b whole square. Okay, but x minus a whole square is nothing but here we have, or y minus b whole square. We have this. We have to use this. See, we have to write everything in terms of c. So what we can do is x minus a whole square. What we can write, c square minus y minus b whole square by y minus b whole square. So dy by dx whole square becomes what? Is c square by y minus b whole square minus 1.
Yes.
This one you bring this side. 1 plus dy by dx whole square equal to c by y minus b whole square.
Yes.
By y minus b whole square. Is that okay?
Yes, sir.
So now what happens, you see here? Here, c by y minus b is c by y minus b is, c by y is whole square, and c by y minus b whole square is this is, 1 plus dy by dx whole square whole to the power whole root. Yes or no? Whole root. Yes or no?
Yes, sir.
Whole root. I think this you understand.
Yeah.
So now we can substitute here, and then we'll get the answer. So if you want, you can write one more time. So 1 over 3 means c2 by y minus b you get, and here also we got here one more. We got. So from these two, we'll get. Okay, I'll write down the final answer here. So little, that's the reason I said this is important. So since we have result there and erasing this thing. So here now, so clear one part actually. Clear one part. After that we did. Yeah, here what happens is here. Now what I want is this thing I want. 1 plus dy by dx, this is whole square. And this is 1 plus 1, 2 I said, right? ये वाला 1 हो गया. This is this into I'll write this one now. 1 plus dy by dx whole square whole to the power of 1 by. See, this is 1 plus.
That will become 3 by 2. Whole to the power 3
Yes.
by 2.
Yes. Yes. So, but this dy by d square y by dx square we want, right?
Yes, sir.
So, okay, I'll write this also. I'll write d square y by dx square. Now, this is what, this 1 plus this whole to the power of 1. This is minus y minus b times d square y by dx square. This I wrote, okay? This I wrote. By.
Yes.
This I wrote. This thing I wrote. Okay, then I have to write this thing I have to write.
C.
That is c by y minus. Yes, c by y minus. I wrote that. And d square y by dx square, I need to write d square y by dx square. You understand? Otherwise, this you bring this side. You all y minus b. Okay. That will also, this also gets cancelled. What you got is minus.
Acha, okay. Yes, sir.
Okay. Thing is here, I think hope you understand. Thing is, see, after coming here, After this here, 1 plus dy by dx whole square divided by d square y by dx square. This is already there. This result is there. This is minus y minus है ना? This result is one more term we need, that is this we need. 1 plus dy by dx whole square whole to the power 1 by 2. That is this. We need to find such a way that y minus b gets cancelled. So here
Yes, sir.
y minus b is like that.
Got it. So it will be like c by y minus b into minus of y minus b.
Yes.
So then y minus b will get cancelled minus c.
Like this, somewhat tricky questions. You need to have proper approach. So if you write the results, you have to see the question. You should understand first question, analyze the question, and you have to have proper approach. Yes. So 16th question. Can you tell me what could be the proper approach? 16. Yes, tell me what. 16. Like this is cos y equal to x cos a plus y, and this cos a is not equal to some of this one. Prove that dy by dx is cos square a plus y by sin a. Yeah, answer is in terms of y. Yes or no? There is no x here.
Yes, sir.
Dy by dx is in terms of y, and of course a constant. So what is your approach? Tell me.
So already we have a plus y in one side of the equation. So we can, I think, do directly derivation. No?
If you do directly, what happens is minus sin y into, yeah, you can take no problem, but into dy by dx. Of course, if you do direct, it's no problem. Yeah, then equal to what? U dash v. U dash is 1. V and 2v dash. 2v dash is cos y ka minus.
Minus sin a plus y into.
This is important. See here, either put into or you can put bracket. Because into and x into, if you write x in x into minus cos sin a plus y, then what happens now? X minus y, this becomes x into
Yes, sir.
x minus y, so you should be careful. Minus sin a plus y into dy.
Into dy by dx.
Yes, this thing you see, if you simplify, you should get this one.
Yes, sir. But it will be longer process.
Yeah, you can. What you can do is this one you bring this side. You have to bring this one. X into minus x, this we have to bring this side. Minus x becomes here, and minus x, and so this
Yes, sir.
x sin a plus
A
into dy by dx minus sin y into dy by dx equal to cos of a plus y.
plus y.
No, direct. But here a plus y is there. Cos square a plus y is there.
Yes, sir.
Yes. So what we can do, dy by dx. Then you get x sin a plus y minus sin
Minus sin y.
equal to cos of a plus y. Like this.
Yes, sir.
Now you see here dy by dx you got cos of a plus y by, this whole thing should be simplified and it should be in terms of here sin a.
Cos.
Yes. So if you have to do that, it will be, I think, it will be difficult.
Yes, sir.
X into sine. So that will be difficult, a little difficult.
Yes, sir.
This will be difficult. Okay, I understand what's the process, but I am just showing here. But anyway, this one is x into sine a plus y. The sine a plus y and this is sine y. This cos y is there. We have to bring it in sine y. So this and here x is there. Like x into sine of a plus y minus this whole thing we have to again we have to change this. Huh? But here x into cos a plus y is there. X becomes what, you know? X becomes what in here? X you have to remove anyway. X we have to remove. X is what? Cos y by cos of a plus y, like this, into sine of a plus y, like this, minus sine, like this. Yes or no? X you have to remove. No? X equal to cos y, like that. What happens? Cos y into sine of a plus y minus the by LCM, this becomes what? Sine y into cos of a plus y. Yes or no?
Yes, sir.
A cos
By cos A plus
a plus y, like this. But you know what? Here, this is sin A cos B minus cos A sin B. You know what is the form? A हो गया, ये वाला B हो गया, वाला A, ये वाला. What is that? Sin A cos B cos A sin B. तो ये वाला हो गया sin of A minus B, है ना? अच्छा.
Yes, sir. Yes.
So sin of A minus B, so you put the values here. Sin of A minus B, ये तो A plus y हो गया, A plus y, B
A
is
plus
y.
Y.
So now what you
So
got?
it gets become sin A.
Yes, sin A. So ये वाला sin A by cos of A plus.
Yes, sir.
Like that. You got the answer.
Oh.
So here x into sin A plus y minus sin y, this you have to remove. Okay, how to do? This is the process. Then you will get, because x we don't want. Answer I already first only I showed you, right? Yeah, there's no
Yes,
x,
sir.
there's no x. So you need to eliminate x, to remove x.
To remove X, we'll go from cos
Yeah,
Y.
from the answer you need to eliminate x. So you substitute x separately. I have taken. If you substitute here only, you need to write all this. You need to write. Instead of that, if you do separately, it is nice actually. Okay, this is one way. So you said this side, you understood, right?
Yes, sir. I understood.
See, you understood, but there is another smart way is there. This is direct and regular, and this is okay. There is a smart way of understanding. What you know that? Cos y rotates cos a plus y. This tablet is smart way. Okay, within 1 minute it's going to go, and we may have to log in again. So what is
Okay.
you know what? X equal to cos y cos of a plus y. This is smart way. You know? Huh. Okay. So everything is in y because the answer should be in y. So
Yes, sir.
differentiate with respect to y. You know, x we are
Oh.
with respect to y.